All right, so now we're into the examples. You need to be a little bit careful because you need to make sure that the triangle may not be given in the same format that it was when we were talking about our rules. So I'm going to draw in a triangle and I'm going to put the information where I want it. So I always want the angle down here, so that's 61 degrees. So that's going to be A. Now I want to know the side length over here. So I want to know that side length. And it's got to be in order here for me. So it has that C is 5.1 and A is 3.1. So I'm kind of locked in. I know this is A 3.1 centimeters. I want to know this side length over here. So it's 5.1. So that's technically my C and this is my B. So we just got to be careful here because we're not actually comparing. It's not the exact same values. So the way I always set it up is I want to find the altitude. All right. So altitude equals B. In this case, it's not going to be B sine theta. It's going to be C sine theta. All right. And the way you remember is that if this is your altitude right here, it's always going to be this value multiplied by sine of that. All right. So you know it's going to be 5.1 sine theta. Okay. So in this case, to keep it correct, the note C sine theta. So the altitude of this triangle is 5.1 multiplied by sine of 61. Now you're just punching it in the calculator. So 5.1 times 61 sine equals 4.5. Okay. I know that the arm BC or A value is 3.1. So I know that my altitude is greater than my A value. So if my altitude is bigger than my A value, that means that this triangle isn't actually like this. It means that I only have a little arm, a little terminal arm. So it's not actually that length, it's something like that. So I have this situation where we can't reach the bottom, so therefore no solution. All right. So the trickiest part here is just getting the information in the right order to do the check. Second example, same thing, draw the triangle. I know I want the angle in this corner, so angle A is 20 degrees, so that's fine. Side A, you're locked in, so this has to be 2.4. I want the other length over here, 3.2, and it looks like this, wherever I got this example from, they're all consistent. They're all labeling it in this direction. So I'm not too worried. Altitude is that right there. So I'm going to calculate my altitude, and it's equal to 3.2 multiplied by the sine of 28. So that's how you calculate the altitude, the height. We want to know how it compares to that arm BC. So 3.2 multiplied by sine 28. I get 1.5. My A value is 2.4. So my altitude is shorter than my A value. So what does that mean? Well, it means that if this is my altitude, my A value is actually longer. So that means that I have, it swings back and forth like the pendulum, crosses here, crosses here. So I actually end up with two solutions. So there are two different triangles possible. So two solutions. All right, and final example, same thing. You have to give yourself a sketch. If you don't give yourself a sketch, you're going to cross up or put the wrong piece of information in the wrong location. So that's A. Side A then has to be over here. I want the other length on that side of the triangle, which means this corner will be C and B. All we're doing is checking our altitude here. So my altitude is always calculated with, and one more time, this length and this angle. So 9.4 multiplied by sine 47, and that's equal to, as I do the calculation, I get 6.9. My A length is 3.5. So this has absolutely no prayer in working. And if you were to use your instincts here, you'd probably be able to tell me this as well. So again, if we were to draw in that line BC, when I'm drawing it in, I know that it is much shorter than the altitude, so I have this case right here. BC, can't touch AC. Can't touch it, therefore this example has no solutions. All right, so that's just identifying. All right, move to the next example. So what happens if you get this drawing, comes across your table if you're doing some design in the manufacturing. So we've got a 3-pulley system. Someone's measured out the following triangle. First thing you want to check when you're in design, and a lot of computer software programs will do this for you, you'll see it visually, but I want to know, or I want to make sure that this pulley system, A, is possible. Okay, so if they tell you these are the measurements, I don't necessarily trust the person measuring them. So I'm going to figure out, first of all, is this triangle possible? So I'm going to calculate my altitude. So my altitude equals the length of this side, so 9 inches, multiplied by sine of the angle, 40 degrees. So 9 sine 40, 9 times sine 40, 5.8. So that's my altitude, and it's in inches. My A value is 7 inches. So now I have a bit of an issue here because my altitude is smaller than my A value. All right, and again, just to demonstrate what that means, it means that this distance here, oops, if I was to compare it, it's longer. So we actually have 2 possible pulley systems here. It's going to be one like that, and then the one that's shown. All right, so conclusions. Therefore, I have 2 solutions. So now you go to call home, or call the office, and they've shut down for the weekend because they thought they got their job done. What are you going to do? Well, you don't want to put this off to the side. So what you're going to do is you're just going to design this system, and you can scold or yell at them on Monday and tell them they got to give you different measurements, or they got to give you more measurements to make sure, because you had to design 2 different pulley systems. All right. So we got 2 pulley systems. One's going to look like this. All right, with the 40 degrees and the 9 inches. This side 7 inches. A big or, so now you're doing extra work because people can't do their job properly. 9 inches and 7 inches. So we have these 2 situations. So what do? Well, you go ahead and use your sine law. Okay, so sine A over A equals sine B over B equals sine C over C. So I know sine of 40 over 7 is going to equal. So now I got to label my triangle, and at this point it doesn't really matter. ABC, so I'll be consistent all the way through. Sine of ABC, so sine of angle B over 9 equals sine of angle C over side C. So I don't even know any information. So really all I can do is find angle B at this point in time. So sine of 40 over 7 equals sine of angle B over 9. So 9 multiplied by sine 40 over 7 is going to give me sine B. So that would mean that angle B is equal to sine inverse of that mass there, sine 40 over 7 equals, so I go ahead and calculate 9 times 40 sine, divide that by 7, shift sine, 55.7 degrees. All right. Now that means that angle C then is equal to 180 minus, we started with 40 degrees, minus 55.7 minus 40 plus 180. So that means it's 84 degrees angle C. So if we look at the diagram now, which angle C and B looks like acute angles less than 90 degrees? Because we've got angle B. Angle B is 56 degrees. Angle C is 84 degrees. So when we look, we have this triangle right here. Okay, because this triangle, angle B, has to be something much, much bigger than than 88 degrees. So that means that over here we know this information. So again, I know that angle B is, let's call it 56 degrees, and angle C is 84 degrees. Okay, so we have this triangle all figured out. All right, so now you know that because they didn't give you the right measurements, you need to go ahead and take care of, well, what happens if they actually gave you the other triangle. So there's some symmetry here to help us. The nice thing is the relationship at angle B is the following. I talked about the cast rule, so just off to the side here. The cast rule, if it was in quadrant 1, the angle, or in quadrant 2, these angles are theta. So theta 1, and that would be the same angle. So therefore, to find that missing angle, so theta 2 is always going to be 180 minus theta 1. All right, so that being said, for the other triangle, we can find angle B very quickly, okay? Because angle B, again, and I'll show you the why, angle B is the first thing we calculated, and it's the base angle down here. It's the one that corresponds to my cast rule that I keep referring back to. So angle B in the new triangle will be 180 minus the 55.7. So 180 minus 55.7, 124.3. All right, which means that angle C is 180 minus 40 minus 124.3. So 180 minus the 40 minus the 124.3, so we get 15.7 degrees. So there are the two answers. I'm going to put this information in here. Now, for reporting purposes, to make your life simple, all I want you to do is I want you to draw, when there's two solutions, draw the two triangles for me, label the information on there. Then we don't have to worry about a therefore statement. Therefore, I know that you are calculating appropriately. Now, a couple hints. When you do this, all right, when you first find the sine law, you will always find the acute angle, or the acute triangle first. So it'd be this one. So sine law will always solve the acute triangle first. Acute triangle first. Okay, that's the nature of the sine law, or the sine function. It likes to find the easiest or the smallest triangle. So it's always going to find that small triangle. So I'm going to tell you right now, if you have two solutions and you go through and you do this process here, okay, you will always find the information for that triangle, the acute triangle. Then this process is the same every time to find the other triangle, okay? So the trickiest part is going to be doing your test, your check. So I'm going to put this on the test. When you go through and you look at the test or the homework, I'm going to say in the knowledge section, here you go. Here are the triangles, determine how many solutions there are. So right away you know it's ambiguous case because they're looking for how many solutions. In the word problem, I'm going to make it clear. You are given information such that you don't know which design, so you need to plan for both, so you need to do both. So if this was the real world and whoever gave you the measurements sent this picture over on the napkin or faxed it over, and you're in the office trying to draw this up, you have to plan for pulleys that look like this, and you have to plan for a pulley system that looks like this until you can verify information. All right? So once you get into it, you're going to realize it's not nearly as bad as it looks for some that are a little worried. That's the homework on page 68, questions 1 through 10. It's just practicing exactly as it looks here. If you have any questions, please make sure you ask me and I'll help clarify. Good luck.